I'll get to you later. No worries. And what's your name again? Orion. That's right. Okay, gotcha. I'm just trying to learn names, so that's my job. Your job is to learn math. So, okay. And you'll notice that the other thing I've got chapter 2 is here for next week if you want to start, and then I'll keep getting the course together so you'll see the other chapters come, but I just didn't want to inundate everybody too soon. So what I'm going to do is this PowerPoint actually has a video in it, so it's pretty sizable. So we're going to see if I can find it. Yeah, I already downloaded it. And let me make sure it's set up corrected. Okay, we'll do it this way. Okay, so today's lesson is about measurement and dimensions. Okay, so Tuesday we talked about different ways of counting and how there was a culture that grouped things by 12 that's connected to the English language, and that's why we in America, way over here, at least have come to be a society that groups things by 12, a dozen donuts, a dozen flowers, right? 12's 12 inches in a foot. So we're going to look at how that relates to measuring. Um, and so you'll see some little quotes in here that might not seem to have anything to do with math, and that's part of it. Is these kind of bring in a holistic view of the topics and how you might apply them in your life. So Robert Louis Stevenson said, "Do not measure success by today's harvest. Measure success by the seed you plant today." So again, we might not understand everything right away, but if we plant the seeds to understanding, that's good. Uh, Incidentally, my grade school was named Robert Louis Stevenson down in Florida. It was kind of like in the 60s. There was a school without walls, which meant there was a lot of chaos. You put grade school students in a school without walls. And I think I heard 2 years after I left there because we moved up, they put walls in. So anyway, so what is measurement? What does it mean to measure something? Yes, sir. What's that? Okay. Okay. Okay, find a length. And when we find that length, what do we end up with? A number, right? So it's a quantity of how long it is. Good. And that number also, the thing we have to remember is it's not just a number, what's tied to that number? A unit. So one country I measure this and I'll measure it in centimeters. Another country I'll measure it in inches and feet and stuff. So yeah, there's always units tied to a measurement. Actually, if you want to stick a rock in it, that's a good way to do it, and it gets some cool air. It sometimes gets a little hot. That's what they have those rocks sitting around for. Now we don't have to worry about it. Okay, so I measure it. It gives me a number um, and a unit. But as Einstein tells us, not everything that counts can be counted, and not everything that can be counted counts. So we can't measure everything. So what are some things people try to measure that you really can't? How about IQ? I think that's the most stupid thing to try to measure because intelligence is different. It's culturally based anyway, and so when one culture starts doing it, they don't really get the intelligence. And this concept that you sort of have a certain level of smartness and intelligence that never changes. Why do we go to schools if that's the case, right? We go to school because we can learn, we can increase our knowledge and our wisdom and such. So we'll get that out here. Okay. So measurement, technically, this is, again, wordy stuff. But basically, we'll measure an object, we'll have some attribute of it, and we get a unit of measure, right? So length was one thing we can measure, maybe length and width, but how long something is What's another type of measurement we make? If you're a wrestler or maybe a boxer, what's really important for those guys to measure? Their weight so that they stay in their weight class, right? My brother was that. If he got too heavy, he was out of his weight class. If he got too light, he was out of his. So he had to keep his weight in a certain thing. So we measure weight, how heavy things are. What else do we measure? Temperature. I would have lost that one. Yeah, so hot, cold, we can measure that. Time, we measure that. We measure just about everything we want to measure. What's that? Force. There's measures of force. Speed. There's all sorts of different measurements, numbers that go with them, and units that go with them. Okay, good. Energy, right? Like BTUs. If you're into air conditioning and stuff, that puts out so many BTUs. That's some kind of measure of energy. And then we compare it to something else because that's what a unit is, right? If I'm going to measure this in inches, what do I need to know? I need to know how long an inch is. We have a standard unit. So we're really comparing how long is this desk in comparison to this standard inch or this centimeter or this meter. Okay, so it's always a comparison to some pre-existing unit as we go to. So now just thinking about things that we measure, if we measure something called perimeter, what are we measuring? So if we talk about this room, it's the outside, so it would be how much baseboard we need. So that's good. But then the next one, so perimeter is one dimensional because it's just a length and width. But if we wanted to get the carpet, what are we looking for? How much carpet we need? Now's the time. Area. Okay. But the thing is we measure them similarly, don't we? If we know the length times width, we multiply them and that gives us our area. But we also could use those same dimensions to figure out the perimeter. But in perimeter, we're adding things together. Okay. So that's where it gets a little interesting. Now this one is about a 5-minute video. Hopefully the sound works and hopefully it's not too loud. And it's sort of a historical view. It'll take you back to ancient India, kind of going with the Vedic math that we learned about measurement systems have been around for a long, long time, but this will show what it can do. Oops, I got to turn this thing off, which means it won't record, but that's okay. So where was I? 2x4. We use it in our construction, flush toilets. The conception is that ancient people were primitive. I mean, that's typically what history tells us, or at least grade school and high school history. We're back in the caveman days, so we think of humans as starting primitive, but we go back 5,000 years and they were pretty advanced. We look at the Incas down in Argentina, what's right above Argentina? Anyway, Peru and Argentina, along that region, they're building. I've got some videos of those too. They were able to cut their stones and they sat together. You couldn't even get a piece of paper between them. That's how accurate they were in their constructions. Again, to do accurate construction of buildings and such, what do you need? Measurements to be accurate. And what they also said is that with Mesopotamia, which is Babylon, over in the Mediterranean area, they had a measurement that was exactly half of this, so that these would work together. Because we got one that's a half and one. See, centimeters and inches don't work together very well because they're not really. It wasn't assigned. It was designed. We're going to use a centimeter and get rid of all the other measurements. That's how they did it. But in these cultures, they said, okay, you're using this one. Let's get them at least that they're compatible, right? Your measurements, we just have to double them. You get our measurements, you just have to cut them in half, or something, one way or the other. So it made their mathematics good because they were working together. That's sort of the thing that we get. So the rest of this class, this lesson, if we can get to the next one. There we go. So we're going to now start looking at the two systems of measurement that we use. Now, if we were out of the US, which I've worked internationally, this lesson's a lot easier if we just go to metrics. Because metric you can convert between them by really just moving the decimal place. We've made things hard by keeping an ancient measuring system that we picked up from the British. So it used to be called the Royal British System, but the British don't even use it anymore. It's now only the US that's still keeping with inches and pounds and all our stuff. So we're going to make it a little harder. So anyway, here's an inch. And what kind of a measurement is this? Length. So it's a single measurement, a single unit. We also can measure, what is that? When we get to area, an inch by an inch, and that's going to give us squared inches because we actually multiply the two together. And the thing to think of is if I've got a measurement that's linear, say 25 inches, is that the same thing as 25 squared inches? No, in fact, you see 25 squared inches is 25 of those squares. 25 inches is just 25 of those straws strung together. So they're really representing different things. So as we look at this unit, we want to watch what are the units singular, are they squared? Or if it's 3 dimensions, are they cubed? Then I've got a little block, roll some dice, right? But that, again, that would be different. If that was 25 cubic inches, that's 25 cubes could fit in that area. So it's again, we're measuring area, which is really different than a length. And did I say that? Volume. We're measuring volume or area or length. Okay. So, but mathematically, if we do volume, it requires multiplying 3 things. So that's why we get the cubed. If we're doing area, how much carpet is there? We've got 2 units, 2 measurements, and so those are going to be squared. And then if we've got something that's just a length, then that'll be 1 unit. So dimensional analysis. So we're going to get into this. So here's the key part. If you divide a number by itself, what do you get? Let's see if it'll let me. Oops. Where is, oh, that's right. If I go this route, I need to use this tool. Yes. It actually already is. Yes. 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 It took even me, it takes a little bit to download because that video is embedded in it, but you'll be able to watch it. So if you want to share it with anyone, but yeah, anytime I use any kind of PowerPoint, I will have it posted in there for your review. Also, you'll have the recordings of as we go through it. Yes, sir. Okay, so there we go. So good. 5 divided by 5 equals 1. 126 divided by 126 is 1. Horse. A horse divided by a horse is 1 horse. Yeah. So think, yeah, but that one's kind of, yeah, what is that? Why would you divide a horse by itself? But the thing is mathematically, when we've got units, we're going to take this process that whenever we take anything divided by itself mathematically, we just becomes 1. So the horse is gone, the units are gone. So we're going to do what's called dimensional analysis. So, but the basic thing is with converting units, you'll see we're either going to multiply by something or divide by something depending upon which way we're going. But the way we're going to set it up is the reason this works is because something divided by the same thing is always 1. Okay, so what do we get when we multiply by 1? Okay, 5 times 1 is 5. 126 times 1 is 126. So no matter what, when we multiply by 1, we don't change the number. That's the key part. So dimensional analysis, converting from one unit to the other, is this trick of multiplying by 1. And remember, a fraction that has the same thing in the top and the bottom is always 1. And that's what makes this work. So let's see how, let's put these together. And we have conversion factors. So if I tell you that 1 inch is equal to 2.54 centimeters, what is 2.54 centimeters divided by 1 inch? Good, you got it. They are the same thing. So something divided by itself. Now they're represented different. They don't look like they're the same thing. Inch is a different word than centimeters. The numbers are different, but they are measuring the same thing. So when I write it this way, it's really equal to 1. It's not equal to 1 centimeter or 1 inch. Everything, it's equal to just 1. And then when we just showed, if I multiply by 1, what happens? Nothing. Nothing changes. But we're going to see that as we do this, the numbers will change, but the amount represented is the same, because this desk is this long, whether I measure it in centimeters or inches. Would you agree with that? The desk doesn't change size. I could call it 300 centimeters, or I could call it, I don't know, 36 inches. Maybe I don't know which one's which. If those were both the same measurement, the desk hasn't changed size, but the numbers that represent it are because we're using different units. Okay, so that's it. The mathematics things seem to be changed, but it's all this concept. We're multiplying by 1, some kind of a 1, and we're getting a new number, but it's really the same length. Okay, and that's really the magic behind this, and we'll do a few of these. And the cool thing is, as we go through, oh, I forget I have to delete. So one of the things we'll need is these sheets. So these are in here. They'll also, when you'll see in the homework, they usually give you these things that are equal. So we need to get a conversion factor. We always need a fact of how many inches are in how many centimeters, or whatever we're converting one from the other. How many seconds are in a minute? If we want, how many minutes are in an hour? If we want to convert from minutes to hours, right? Whenever we're converting from one thing to the other, we just need how many of these are in how many of those. Okay, and then we always get 2 conversion factors actually. So from that last one, I wrote 2.54 centimeters over 1 inch. That's 1, right? But what about 1 inch over 2.54 centimeters? What is that? It's also 1. So 2 ways to write 1. We can, and we'll see. We'll use one or the other of these. So this is the big part. Is first you'll see there's going to be 2 things that are equal. You can write them as a fraction of one over the other, but you can write 2 different fractions, and they're both 1. One of them we'll use, the other we won't. It just depends on which unit we're going to the other, and we'll see how this all sets up. And once you've got that in case, everything goes forward. And you'll see in the end, we're always generally either dividing by a number or multiplying by a number. So some of you have maybe an intuitive feel for things. You just know, if we're going from this to this, we multiply. We go from that to that, we divide. So you may have sort of a gut feeling on some of these. But what we're going to do with the unit analysis will help you sort of formalize it. Okay. And then the metric system has another sort of, you know, how many milliliters are in how many liters. So there's these conversion factors. We could also look them up on Google. You'll also see there's online calculators. There's going to be one that I suggest. It's that is an app. I've got it on my phone, and it will actually do the conversions for you because it's got all of these things stored in there. What's kind of cool is the same things happen if you do any international traveling and you need to change your money, right? $1 buys so many euros and um, that same type of thing. But those conversion factors change, don't they? Sometimes $1 buys more euros, sometimes it buys less. So that app will actually go to the internet and update. So when you're traveling, it'll keep track. How much is my dollar worth today? Um, but that's exactly this. The mathematics we're doing can be applied to all of those. Um, with the metric system, each measurement, each unit is 1/10 bigger or smaller depending upon which way we go. So it makes things nice in a sort of way. Um, but we've got these Latin prefixes. A lot of them we don't use. How many, is anyone doing biology? No? If you're into maybe like viruses and stuff, you might be into the nano inch, really, these are with negative exponents. These are really small measurements. Uh, a lot of us might use millimeters, milliliters. You'll see that maybe in your medicines. So that's a, a thousandth of the unit, a milligram. So I've got a gram, a thousandth of a gram would be a milligram. So we see that. Sometimes we centis, centimeters get used a lot. Uh, this prefix usually doesn't get used that much, a deci, because that would be a tenth of something. So it would be 10 centimeters, but a tenth of a meter. Again, it's there. You could use it, but most, in measuring systems, you rarely ever see it. Okay. It's bigger than a centimeter, which is two two. Yeah, but it is smaller than a meter. It's because in the metric system they start with a meter, a huge, it's about a yard, a little bit more than a yard. In our American system, we start with a foot, which is smaller. Okay, and then you have these other ones that go up, deca. Again, a lot of times it doesn't get used. That would be 10 meters. Um, a hectometer. Again, we don't use that. You might see when you're driving a kilometer. That's 1,000 meters. So that's a standard unit. And then the mega and the giga. Again, you're probably familiar with that with computers. A gigabyte. There you go. So it just and then yeah, that's yeah, the next one. And so there's all these ones, and again, depends upon what you're doing and what you're measuring. And I hadn't even thought of measuring computer memory, right? That's a measurement. Uh, I believe so. But don't quote me on it. I'm not an expert, and I'll say it's one of those things I don't pay that much attention to. But we start need to because it didn't used to be a big deal, but now we can get a terabyte. I believe it's right afterwards. So that's the metric system. And again, part of it is when we think of a unit, how big is it? Because we need to know. So a meter is maybe like that. Again, it's not exact, but we have to get an idea. It's not like this, it's more like that. Um, how big is a centimeter? Well, it's a little thing. Again, I'm not real accurate, but so we start thinking about what would I use to measure it. Certainly, I wouldn't measure an ant with a meter. Maybe I'm not even a centimeter. Maybe I go to a millimeter. So those are some of the questions that kind of get up. Is a millimeter is even it's a tenth of a meter, so it's small. Kilometer is yeah. That's when I'm driving. That's in a race or something. It's 1,000 meters. It's pretty big in comparison. A liter, you start thinking, a jug. You compare it, maybe here we think about gallons, a gallon of milk, and that's about 4 liters. It's a little bit less than 4 liters, but you do that. Milliliter, a thousandth of a liter is. So it's those are the kind of things. And then part of it, you'll see some activities where you're going to convert from inches to centimeters, gallons to liters. And as you see, I said approximately 4, it's actually 3.79. And that's even an approximation, which means it's rounded, right? It might be 3.791 or it might be 3.786. It's a rounded. Uh, and when we're doing the homework, whatever they provide you, use that one, because sometimes if you use the app, you'll get more. The app might have more decimal places, might be more accurate actually, and the homework system will mark it wrong because it's using the things it says. But again, all of this is find a piece of information. Let's go to weight. 1 kilogram is 2.2 pounds. So what are the two conversion factors we get out of that? We get 1 kilogram over 2.2 pounds. What's the other one? Exactly. And again, now we'll get it when we get into this, we'll see, then we'll decide which one we use it. So remember, dividing out does it. So this first one we use if we're going from pounds, LBS, to kilograms. That's the one we're going to use because we want to divide out the pounds. This one over here we use when we want to go from kilograms to pounds. So it's whatever we're trying to get rid of is in the denominator. Okay, so this would be kilograms going to pounds. And we'll look at a few examples. We're almost done with this part. But that's the thing. So you're going to get the fact or look it up. It'll either be given to us. We look it up. This equals this. I get two fractions. Which one do I use? And then I multiply by that fraction. And you'll see how that all works. Okay. And I got this from someone else. So yes, sir. You got it. So what the teacher says in the classroom is not unimportant. Sometimes it's not always important though. But what the students think is 1,000 times more important. Empoya wrote a book called How to Solve It. So he was a mathematician and problem solving, how to solve a problem. And his was not so much the techniques of math as much as the technique of thought. How do we solve problems? And that's what I hope you get out of this class as well, as thinking of different, how to use math to solve different problems. And again, we could even think, emotional problems. You have a situation, if you want to de-escalate, what do? You kind of try to match, and then you come down. If there's a lot of anger, you recognize that, but you want to pull the anger back. If there's, so how do we measure anger? Well, I don't know if there's a unit for anger, but when someone's got a lot of anger, right? When there's little anger. So it's that. So converting between. This one I'm going to kind of go through quickly. This is somebody else's PowerPoint that I used for a math elementary teachers. They use this idea of copies of. We're going to go through, because what I did like about it is not the copies of, but this part. If we could compare things. If I know there's 12 inches in a foot, right? And I know I've got 14 feet. What's another way? So we could do dimensional analysis. We can take that and multiply, but what would I have to multiply 1 foot by to get 14 feet? 14, right? 1 times 14 is 14. So we set that. So what do I have to do to the other side? Multiply by 14. And that gives us our answer. So this is one way to think through it. Because what it is I want you to see multiple methods. When we get to it, we're also going to use this, what they call dimensional analysis, using the fractions. But you can also, if you look at this, 1 going to this, just multiply by it. Okay. Um, the other side, now I got it 12 inches and I'm going down to 4 inches. How do I get from 12 inches to 4 inches? Divide by 3. See, I told you we're either dividing or multiplying. Or I could multiply by 4/12, but I'm going to divide by 3. So what do I do to 1 foot? Divide it by 3. Yeah, I don't like this copy stuff. I can't even really understand that. But 1/3 foot, right? I got to the answer faster than they did. But okay, so we're dividing by, um, and you saw that. You did that in your head. You said, well, I got 4, I got 12, so 4 divided by 12 is 1/3. We can do that. So you'll find some things you'll be able to kind of do that way. The other one is this is what's called dimensional analysis. And this is kind of what our system is set up to do is if you've got 4 inches and you want to find out how many feet, you multiply by 1 foot over 12 inches. Remember, in that, because 1 foot over 12 inches is equal to 1. When we multiply by 1, we aren't actually changing anything. However, it does change the number and it changed the units. So we go from inches. Notice inches are sort of, I'll go ahead and write this out. The inches are canceling out. You could think of this as 4 inches over 1. And then the units that are left are feet. There's 4 in the top. 1 times 12 is 12. And then 4 divided by 12 is 1/3. So this is what's called dimensional analysis. Again, another way. And notice we did it before. We could just kind of say, oh, I just need to divide by 3. Boom, done. Or I could use this if I'm not really sure of the process. I could say, well, I know that there's 12 inches in a foot. I want to get rid of the inches, so the inches go in the denominator, the feet go in the top, and we're good. And again, this is the part that I don't really like. Maybe I should just delete it, but sometimes I might need it. So this one, again, we're going to go multiplicatively. We're going to use multiplication. Let's just use English. So if I want to go from miles to feet, I know I've got 9.2 miles. How do I get from 1 mile to 9.2 miles? I'm multiplying by 9.2. So what should I do to the other side? Multiply it by 9.2. So it's kind of like starting with the conversion factor and just using that as a tool. Well, that means in 9 miles, there's 9.2 miles, there's 48,000 feet. Okay, so maybe you're like in an airplane, right? At 50,000 feet, you're 9 miles in the air. Kind of do that. Okay, so that's one way. Again, we could also use the dimensional analysis way. The other thing is you can do reciprocal. So in 1 foot, there's 1 divided by 5,280 miles. So that's well, an inch is like this, right? But a mile is probably longer than we could think of. But if I wanted 457 feet, multiplicatively, how do I get from 1 foot to 457? I multiply by 457, so I could do it on the other side too. Again, just another way to get there. And you see, I get a fraction, but that's how many miles are in an inch, right? It's not much. Here's what dimensional analysis, again, multiplying by a conversion factor. So that's one of the processes we're going to use. We get that same answer. And again here, just to kind of highlight, the units we're trying to get rid of go in the denominator, right? And then it's really a division problem. I take 457 divided by 5,280. Okay, how are we doing? About ready to be done? Because again, a lot of examples. Dimensional analysis. Oh, maybe I should slow down here. When we go from, that was with linear measurements, there's one dimension. What if we have multiple, if we have like area, right? Area is square yards. So what we have to think, if there's 3 feet in 1 yard, how many square feet are in a square yard? Or how many, yeah. So we think if we've got a yard, how many feet are in a yard? 3. So there's 3 coming from that direction. And this yard also has 3 feet. Now it's not drawn perfectly, but how many squares do we have in here? Each one of these little squares I just draw is a square foot. 9. So we're basically squaring both sides, right? So in 1 square yard, there's actually 9 square feet. Okay, so it's kind of like use the conversion factor twice because we have 2 dimensions. I think there's a couple in the homework that have you do that as well. But you'll just see I like to think, okay, I've got 2 dimensions, just use the conversion factor twice. 1 to 3, 3 times 3 is 9. So we could do that. And what will this, that's the last slide. I think that's enough of that. Let's not save it. Let's go ahead and get to our homework quiz. And again, if you've got yours, you could pull it up. If not, you want to take notes. If you want to just remember this is being recorded, I think. Yes, it is. I'll do a teacher preview. And what we'll see is the reason I do these are 6 questions. So you'll see we'll kind of have a presentation last a little bit less than an hour. We'll go through these, maybe 15, 20 minutes. We'll be getting the quiz done. But again, your numbers may be different, but sort of just take notes on the system. You'll be able to get the quiz done fairly quick. And then you'll go back and do the homework, which has other problems as well, but this will at least kind of get you started. Let me do this. Let me make it larger, right? I guess that's not too bad, but my eyesight is not real strong, so I'm going to, for my efforts, if I make it a little bit, and then I don't need this thing, that's right. Let me get that out of the way, because I've got a different one that works. Let's go with bright red. Okay. So kind of work these together. A long year-end status report for work is 143 pages long. So what I do is I look for numbers, and when I see a number, I underline it because that's probably. So we need to print 13 copies for a meeting next week. How much is a paper going to cost for those reports? Oh, this is question 5. Should we start with 1 or? Okay, I thought this was question 1. Since you want to start there, we'll start with question 1. Kind of, I think better. Let's delete that. Okay, there we go. I was kind of out of there. Okay, so now units, right? This is what we're talking about. Okay, find the unit rates, if necessary, round your answers to the. Now, what's a unit rate? A unit rate is a cost per 1 unit. Okay, so we didn't talk about this in the slide. This is why I come back here, is that we find anything we might have left. A unit rate is the first one. They want dollars per pound. And whenever you read this, what is per? You're good. It's the division part though. So it's telling us a numerator and a denominator. Okay, and we're going to get it. And notice they want then pounds per dollar, which is usually not how we think. We think of how many dollars per pound something costs. When you go to buy chicken, $4 per pound, something like that. So what we're going to do is dollars per pound. You take the dollars, you put that in the top, and notice you'll have dollars there. And then the pounds, you put that in the denominator, 12 pounds. So when we're done, we're going to divide these 2 numbers. And by doing that, we're actually, it's like turning the denominator into 1. We're just going to get a number. And the units are going to be dollars per pound. So could someone, well, I guess I could pull that up. I think I have a calculator here somewhere. Let's see. I don't want to use the fancy one. I want a simple calculator, so let's do that. well, not too simple, but so 8.89 divided by 12.741. And then round your answers to the nearest hundredth. Hundredth is how many decimal places? Two. The decimal point is not, so when you start to the right, it's tenths and then hundredths. There's no ones place. So think of how many zeros. So 100 has two zeros, two decimal places. So when we're going to round this, it's going to be 0.74 because next to the 4 is a 0. So we round to just 0.74. And I'll actually enter it because then it'll check it for us. You could put the 0 if you want, or you could just do 0.74 for these. Okay. So that means 74 cents per pound for whatever we're buying. How about pounds per dollar? You do basically the same thing, but they're reversed. So for $1, how many pounds can you buy is really what you're going to get. So 12 pounds goes in the numerator. Dollars goes in the denominator. And again, when we do the division, we get a number, and we get our units are now going to be pounds per dollar. And again, it depends on what you're doing, that maybe this is more important to you. And again, you could just take the reciprocal, I guess, but let's just go ahead and start off. So this is unit rates. So we're not converting yet. Did I get that right? So you can buy 1.34 pounds for $1. Actually, not 1.34. We're supposed to round it to the hundredth place. So what do we do? 1.35. And I'll check our answer. Got it right. And on the quiz, I think you get like 2 attempts at it, maybe 3. But if you need more, let me know, and we'll, you know. Right. So you want 2 decimal places, so it would be 1.0. So if you round a 9 up, what do you get? You got it. And technically, you could write it so if the next one gets rounded up, so because you round 9 up, you get 10. So it would be 1.10 technically. I always like putting that 0. You don't have to, but it reminds you that that 9 became a 10. So, yes, sir. Of course, anytime. It'd be 0.10. Yeah. So if you had 0.9. Okay. So to the hundredth place, what's over here? 0. Okay. So that will just round to 0.91 because you're rounding to this place here and just keep it down. Is that good? Okay. Yeah, and incidentally, if you need to step out for any reason, you can, yeah, use the restroom, get some water, get some fresh air. That's right. Yes. Right. So I'm giving you the template of how to do it, but this thing randomizes the numbers. So generally your numbers are going to be different than mine. But you'll see like this, we probably both have meters. Um, yeah. Meters, 1 meter equals 100 centimeters. Okay. And so they want us to do the factor thing. So what's kind of cool, I think, I don't know, it seems kind of cool to me. Anyway, we have centimeters and we want to turn it into how many meters, right? So to get rid of centimeters, where do we put the centimeters? On the bottom. So that's what this one's kind of teaching you. So this is the conversion factor. 100 centimeters is equal to 1 meter. And I mean, you don't really have to have this here, except that it does score it, but that's just that's the process. So to get our final answer, what's going to happen? Centimeters will cancel, so our final units are going to be meters. We're going to take 379 and divide it by 100. Bless you. What does that give us? Oh, good. I was going to go with 0.3, but you got me. You caught me. We move the decimal over 2 places when we divide by 100, so that's going to be 3.79. Very good. Now, again, you could use a calculator on it too if you weren't sure, and maybe I should. I usually do because I put my decimal in the wrong place, but dividing by 100 moves it 2 places. That's where the metric system has advantages. Calculations are usually easier because you're just moving the decimal place, but make sure you have a friend who can help you make sure you get the right number. Otherwise, I was going to. Of course, you always check your answer. If you got it wrong, you say, "Oh, I went too far. Come back one more." Okay, so that's what's nice about this, and you get multiple attempts. In the homework, you get unlimited attempts. And yes, yeah, and I can change that. So if you find it um, not working for you, let me know, and we can make this class be whatever we need it. So here again, same thing, right? We want gallons to be miles, or how far can it drive on 45 gallons? Your car can drive 390 miles on a tank of 31 gallons. So this one is not really a conversion, but we use the same process really. Um, we're either going to use 390 miles over 45 gallons, or 45 gallons is 390 miles. And when we're doing this, this is really saying that that's one trip or one tank of gas, right? So we're going to use one of these. So if I've got gallons and I want to figure out how many miles, which one do I use? A or B? Good. I want to divide out the gallons. This is the way you want to think. I always kind of have the wrong impression. I want to use the wrong one. I go, oh, wait, no, I got to divide it out. Because I see the gallons. Oh, I want to put gallons in the top. No, you can't put it in both. So, um, so again, here, the gallons are going to go in the denominator because we want to get rid of them, which means the miles are going to go up here. And the factor we're using is that you get 390 miles on 31 gallons. So this one actually has a multiplication and a division. Okay, takes 45 times. But notice the gallons will cancel out, and our answer is going to be in miles, and that's what they're asking, how many miles can we go? And this time they want it to the nearest mile, so if we get a decimal, we're going to just round it to the nearest one. Pull that one up, clear that. So we do 45. I like to just go straight across times 390, and I'll do equals. And then we divide that by 31. We had 45 gallons. 566 miles, right? Rounded to the nearest mile. But that's got me asking, where do we put the extra gallons, right? Car can only hold 31. How can we have 45 gallons? I guess you bring a gas tank, or maybe you stop at a gas station, I guess. But it seems like a strange question. I did have a car that somebody put in an extra gas tank. I guess maybe they were running down to Mexico or something. It was a diesel. Had an extra 25-gallon tank. That's kind of cool. I could drive for like a month without filling up back in the day. Okay, so this one got what are we going to put in the denominator? the miles, right? Because we want to get rid of miles and we want to end up with gallons. So it's just that's what this will get you to practice. We'll put our, and that means that gallons go in the top. And again, the numbers are the same that they gave us up here. So whenever they give us those are kind of going to be setting up our factor, conversion factor. Oops, 31. And then in this time, we're going to end up with gallons. So to go that many, we're going to need quite a few gallons, right? Exactly, exactly. So that's the nice part about this. Once you have it, just multiply straight across and then divide. Um, and it's sort of a process. Once you get it down, you don't have to think too much about it. And that's a lot of times what we're doing with the problem solving is we're trying to get methods. But be careful, always check it, see if it's reasonable. That's a lot of miles. We should, yeah, about 100 and nearest tenth of a gallon, so 133.5. That would give us a tenth because the 3 is after the 5, so we don't round up. 133.5, and then make sure you write the right thing. And again, check your answer, and it's good. Okay, so you just see this is giving you some practice. You go in the homework, you'll get more practice, and because you'll probably see this exact same type of question. Um, good so far? Now, the thing is now with question 4, we're going to get where we don't have this, it's not helping us so much. And this is usually the hard one. Because actually, so we're going to buy some gas. Cost of gasoline in Berlin was around a dollar, 1.24 euros per liter, right? What would the equivalent cost be in US dollars per gallon? So how many conversions are we going to need to make? 2. Exactly. So there's 2 things. We're going to set it up and make it look like it's one calculation, but we're going to have 2 factors, and I'll show you how to do that. So what we know is the first thing is we have, let's do it up here, 1.24 euros, and that's kind of a funky E. I'll just use that for euros per liter, so that's really per 1 liter. I'll do a scripted L. So that's what the cost is. We want to convert it to dollars per gallon. So we have 2, and maybe this is helpful. They're giving us 2 conversion numbers, right? So let's look at the one. First, 1 US dollar equals 876 euros. So how are we going to convert from euros to dollars? Using that, what goes in the denominator? Good. So euros is going to go in the denominator, so that's 0.876 in the denominator, and 1 US dollar goes in the numerator. So now, as we're going, I like to do this. The euros are going to cancel out, so I now see this will be my final unit. Okay, I'm in dollars, but I'm still in liters, so how do I go from liters to gallons? I need to multiply again by a conversion factor. Now I just have to decide, do the liters go in the denominator or in the numerator? Numerator, because they're down here, they have to be opposite. Good. So you're, like I said, I usually mess this up when I'm thinking through it. And if I don't write it down, I come up with weird calculations. So that's the number of liters equal to 1 gallon. And then again, I like to say, okay, the liters have canceled out. So now I've got gallons. And what I do is I multiply straight across. So 1.24 times 1, that's a nice easy one to do, right? And then I multiply by 3.76. So let's kind of do this step by step, I guess. So I multiply the numerator times 3.785. I end up with 4 point, let's see, per gallon. And they don't tell us what to round it to, but since we're putting in dollars, would it make sense to round it to the nearest cent? So 2 decimal places. Uh, However, when we're calculating, what we want to do is during the process of calculating, we don't want to round yet. So I'm actually going to write down all 4 of these. Let's see if I can. If I can get my pen back. There it is. Um, what was it? It was 4 point, anyone remember? 4.6934. So that's what's in the numerator. The denominator, I've got 1 times 0.876 times 1. Okay, I don't even need the calculator for that one. And I just remind myself I'll have gallons here, I'll have dollars here. So now I just divide those two and then I'll round it. Okay, then I'll round it. So I've got my this, and then I'm going to divide it by 0.876. $5.36, rounded up. And hopefully, and again, sometimes this thing is kind of funky. We put the right answer, but it wants something else. What was it? 3 point? Does anyone remember? See, I can't remember past 2 seconds ago. 3, 6, 3, oh, 5. See, I remember backwards. That's my problem. 5.36 should be the right answer. The nice thing in teacher mode, I can always do a check. But I can check here. You can also do the check, but does that make sense though? So and if you go into chemistry, if you ever take chemistry, in chemistry class, they do these kind of conversions a lot because you have to convert units of energy or something. And so there's like sometimes there's 3 or 4 conversions all in one time. But it's the same thing. You just say, okay, I want to get rid of this unit. I want to go to that unit. So I divide it out. That means that what goes in the numerator. But just kind of think through it. Okay, cool. So we got 2 more to do, and then, again, we'll finish the day, and we'll at least have our quiz. We'll really have half your homework done, right? Sort of half the quiz part, and then all you got to do is work through the homework. What are we doing next Tuesday? Yeah. So if you get it all done, what could you do? Go to the beach or whatever. Yeah, there you go. So that's my encouragement to keep, if you work through it. But if you need help on something, get stuck, please do come here. It's not that I'm trying to say don't come to class. No, it's a work session though. But I don't want you coming expecting me to do something when actually just going to sit here and got any questions? No, I don't have questions. Well, I don't have. So, but if you got questions, that's what makes it come alive. But if you get it done early, then you've opened up some schedule. Um, okay. No, because then I get 100 emails saying, and I'll know because when I check the grade book, I'll see you're done. Um, but I'm also not going to check up on, it might be something. But if something comes up and you want to, you can, but you don't have to. Remember, you're not getting any points for being here, and you're not losing any points for not being here. It's just a matter of learning. Okay, so that's what it's about. Okay, now we're back to this one. Two last ones to go. Jeez, I can't even read now. A long year-end status report for work is 143 pages. Here's my, again, so this is not really a conversion. You will need to print 13 copies. How much is the paper going to cost for those reports? Paper is sold in reams of 500 pages for $3.23 each. So what kind of is our process here? Awesome. That'll tell us what, how many pages we need, right? Good. Because, and always, so this is pages. So that gives us a number of pages. Um, how much? Oh, I, oh, you're on to the next. I thought maybe you already did it for me, but eight, 1850, 1,859 pages. Then what will we do? Right. And there we go, because we're buying in groups of 500. Now, this is assuming you can buy a partial ream, which I don't think the store will open it up and just give you a few pages, but let's just, yeah. So now we're going to divide by 500. And notice that's pages, so we're getting rid of pages. Um, so that'll be reams. This is 500 pages per ream. So you kind of see the connection. Um, where are we? Good job. 1859 divided by 500. So that's how many reams, 3.718. And again, as we're doing calculations, it's best not to round until the very end. So 3.718. So reams, yeah, 500 pages per ream. So that tells us we've got to buy 3.718 reams. And how much does each ream cost? So what do we do with that number? We times it. So thinking each time with all of these steps, we're either going to multiply or we're going to divide. And usually if I'm not sure, I do both of them and figure out which one seems more reasonable. But so we divide or we multiply this number by 3.28, which we already have it in here, 3.28, $12.20, because the 9 gets rounded up, so we carry over $12.20. So we'll just put that in there. Oops, didn't like it. Let's see. I can. Okay. So that, I'm glad somebody was watching. Okay, and that's so it caught me on that. What did I do? I, uh, okay. So this should have been 3.718. See if we get. Oh, this was 3.7. What did I? Okay, I'm doing something wrong. Okay, yeah, it's 1201, not 1220. So let me get rid of that. Um, there's one correct answer if I can get my numbers in here right. Let me come back here. 500, 3.718 times, let's see if I can do this, 3.28. Oh, I'm using the wrong number because I can't, oh, 23. Okay. I do this sometimes, and if you've even some of my videos, they'll say, "How did you get from this one to this one?" Well, I copied it wrong, or yeah, I saw it wrong. Okay, thank you. Now, yeah, that's $12.01. See, that's the correct answer. So, what was that? $12.01. So be careful. Yeah, 323. Yeah. So that's not 8, that's a 3. Okay. Just be careful. Okay. So yeah, you could combine these into kind of like one step is what you're doing is your what so what she said is you would take the $323 and get a unit rate, right? 500 reams here, and then okay, very good. So that's kind of how the lesson showed you. So, but what I wanted to show you is you can also do it sort of just problem solving your way through. So there's multiple ways to think through a problem. And if you use the right numbers, you'll usually get the right, if both methods are right. But if you copy down the wrong numbers, you'll never get the right answer. So I kept using an 8 and I just couldn't get past that 8. Just because be careful. And sometimes that's it, is you think, you get frustrated and I think I'm doing this right. Either the system's wrong or I don't know what I'm doing. And I knew what I was doing, but I just had the wrong number. Okay. And so we'll check our answer now and good. All right, one more, and then we'll have our quiz done, or at least all the methods. And again, I think you'll see also that will kind of help you speed you up through the homework because we've got to start here. So bicycle is traveling 18 miles per hour, which always gives, all right, so good, very good. So yeah, you guys are helping me out here. So how many feet will it cover in 25 seconds? So what do we have to do? We've got how many conversions here? Well, we want to go from miles to feet, and then we also have to go from hours to second, right? So which one do you want to do first? How many feet are in a mile? 5,000. Good. Thank you. And again, that's something I was going to do 380, or 830. I get it all messed up, but it was earlier in the lesson, so maybe you could check it for us. So there's that many feet in 1 mile, and notice we want to get rid of miles, so we can use it down here. So that gets us, again, what we kind of do is as we go, the miles will cancel. That leaves us with feet. That's good. We want feet per seconds. Now, hours, how do we get to seconds? Well, I know that in 60 minutes in an hour, right? So 1 hour equals 60 minutes. So the hour goes in the top because we want to get rid of it. 60 minutes goes down here. But again, I'm checking it. Well, the hours are gone, but I've got minutes now. I don't have seconds yet, so I've got to do another conversion. This is what I mean is, now, yes, you could go ahead and kind of do that and say 60 times 60 is 3,600. But yes, 1 minute is 60 seconds. So we're dividing by, yes. And as you see, we're either going to multiply or we're going to divide. But what ends up happening is using the dimensional analysis, we got rid of the units we didn't want, ended up with the units we do want. So we're going to end up with feet per second. We multiply straight across, so that's 18 times 5,280. 18 times 5,280. And then we're going to divide by 60 and 60, or you could multiply 60 times 60, and that's 3,600. I'm going to do it in two steps because I'm prone to error. So I divide by 60 and then then I divide by 60 again. So just watch what you're doing, especially with these calculators, because they don't always record the steps. And you just saw I hit multiply instead of divide, so that would have caused a problem. But 26.4, so what is that? 26.4 feet per second. Round your answer to the nearest tenth of a feet. Oh, thank you. I forgot about that. So that's how many feet we're going to cover per second. So this is now, that's my speed, is 26 feet. Thank you. See, I was going to get it wrong. Per second. But we want to find not how much we went in 1 second, but how much we went in 25 seconds. So yes, now we're, and I sort of checked it. I saw, how do I end up with just feet? Because I had feet per second, right? Now we're going to multiply this by 25 seconds. Thank you. You guys are good. That'll cancel. And so 26.4 times 25, 660 feet. Right? Yeah, that's going to work. So 26.4 times 25. But we use these units because every number always has something with, it's it's a count of something, whether it's oranges or apples or people or feet or inches. So if we put those units with it, you know what we're counting and it helps us out. But now we're just down to feet. Does that make sense? Feel like you're ready for the homework? And again, we've got 40 minutes if you want to hang out and get to work on it. If you want to go get some coffee somewhere, lunch, and then work on it, that's fine. It's up to you. Do what works best for you. But I'm here. And then Tuesday, just a work session. So, yeah, if you want to want to get out of the house and say, I'm going to go to school, but you don't come to school, that's yeah, like Pinocchio, right? I'm going to go to school. Oh, no, he went off. Be careful where, yeah, don't get yourself into trouble. But we'll be here. Yeah, there we go.